So first of all, I'd love to ask you, Kay, if What is Life or Schrödinger has influenced you in any way throughout your career, directly or indirectly, big or small ways?
I mean, I think asking this type of question, I mean, in a way, the box is like the skull, and, you know, all of our cognitive processes and emotions are within it, and we can't, you know, we can sort of get at it, but not quite. So I think it's a really beautiful analogy. And actually, my father is a string theorist, and so it's nice to see physicists crossing that line. So I think it's been hugely impactful on the entire world, not just me. But yes.
Well, I suppose days like today must be like conversations between you and your father, where you have lots of different disciplines coming together. How do you think that affects the path of science, or what do you think are the benefits that we can get from that?
Especially neuroscience is by nature sort of a Frankenstein of different disciplines. And it is biology, but you have to know a little bit about electrical engineering and physics and, you know, genetics. You just really have to have a little bit of understanding. And so the breadth that Schrödinger had, you know, they were mentioning yesterday in the poetry reading that he might not have had as much depth as some other physicists. This is not my words, but what really made him special was his width of knowledge was I think the quote. And I think as a neuroscientist, you have to be interdisciplinary. Even if you're a relatively focused neuroscientist, I think that's absolutely necessary because, you know, just the way that neurons communicate, electrical and chemical, right? Like you have to have both of those pieces of understanding to understand just the synapse and just the most simple unit of information processing in the brain.
That's a really good point. I never thought of it like that. So you work specifically on emotion. How would you explain your work and how you approach that?
I think emotion, when you say the word emotion, you think of psychology, you think of fluffy things that are kind of theories that can't be tested, and I think that was always my goal. I think emotional processing was one of the curiosities that really led me into neuroscience. And then the thing that I was sort of unsatisfied in psychology was that you can't know if you're correct. You can't test it. And what is the experiment that you can do? And I try to take these psychological concepts and ground them and bridge the gap between psychology and neuroscience and ground them into cellular mechanisms. So I think that's kind of what my lab specializes in. So we record from individual neurons at the individual neuron level, looking at coding properties in vivo or looking at synaptic physiology properties ex vivo. We have all different types of recording approaches in the lab. We're sort of agnostic to technique. We're really question-driven. So yeah, I guess that's my general approach.
I've never heard somebody describe themselves as agnostic to technique, but it makes so much sense.
I mean, I want the technique that will give me the information I'm looking for. And sometimes we do. So we have a paper that is in press at Nature right now where we basically did the same experiment, both with calcium imaging and with photo identification. So physiology and calcium imaging have their different pros and cons, and also completely different caveats. So if you get the same answer using totally different techniques, then you know the answers, or you have greater confidence that your answer is correct. So I think that's how I would generally think. I mean, techniques are great, don't get me wrong. I mean, technology development is essential for progress, but I don't feel any sort of attachment to any individual one.
It's like form follows function.
Exactly.
So your area of research, how would you like to see it progress in the future? What would you like to see happen over the next 75 years? So
right now, the field is sort of exploding. It's at the early phase of what I would consider this proliferation phase. So it's, I think, out of infancy and into toddlerhood. And so a lot of, there's a lot of people, fantastic scientists active in the area, which is great. I think modern neuroscience technologies are being applied. I think what we are weak in is computational modeling. I think that's really the area where I can see immediate steps for improvement, and then really integrating everything. And emotions are not static. Internal states are not static, and they're dependent on each other, and what are the best proxies for those internal states? And so that might be a challenge that may or may not be solved. But I think certainly handling big data, computational modeling, and integration of different subfields.
So I want to ask you about one more thing. I do some work on supporting LGBTQ people who work in science and to make sure they're happy and supported in their workplaces. And I read the philosophy section on your lab website, and I just thought it was so supportive and so welcoming. Could you tell me a little bit about that and why that's so important to you?
Absolutely. What I strive for is to make the lab a warm and welcoming place. We are pretty intense also, and everybody's got their different personalities, and I think it's interesting when people first come to the lab and we interview new people. Oh, and so in my lab, all the hiring decisions are unanimous, so everybody participates in them because, you know, why should one person, particularly someone who might even be in the lab less than some other lab members, be the decider for something that affects all of us? So we all decide together, and I think at first people are always like, wait, why would you be interested in hiring this person? And it's like, because we don't have anyone like this person, you know? And I think diversity in terms of everything, obviously gender, ethnicity, LGBTQ, scientific background, perspectives, just all types of personalities. I think it really enriches the science. And, you know, sometimes you don't realize what you were missing until you bring someone in who's really different. And that is so fun when you bring in someone who adds diversity in any element, honestly. And you can see how it affects the rest of the group. And I think in some ways that, you know, if people think very differently, sometimes that can actually create conflict. But I think it's really important and productive and educational conflict that should and I think must happen. And so it's good to have a safe environment where we sort of all unconditionally support each other to have those conversations. But I think I've learned a lot about many different perspectives through having people in the lab that are different than myself. So I think diversity is the only obvious way to go. I think it actually makes the science better. It's not just for the philosophy, also for that.
That is a perfect way to finish. Thank you so much.